stratification means if you have two different components or if you have three different components together in molten state or in solid also, if there is a difference in density, for example, between the three components, so they will form different layers. So the component having higher density will remain at the bottom, the component having intermediate density will remain at the middle, and the component having very low density will remain on the top. That is called stratification. Stratification means they will form different layers at the end. Fine. So this is, you can see now, this is stratification here. This one actually. This one. You can see the denser particles are at the bottom, right? Then lighter, then further lighter, right? But the point is, this is coarse, this is fine. Is it okay? Anyways, so jigging actually, let me clarify this one. If you remember the previous lecture, we have discussed about jigging and we have seen different kind of jigging, right? You remember that? Right? For example, you take a water container and you take a basket having pores at the bottom of the basket and you pour all the minerals into it. Suppose after classification, you pour all the minerals into the basket having pores, right? And you allow the basket to go into the water and you take it out again. You allow it to go into the water and take it again out, right? So this will go on continuously. So basket is going into the water and coming out of the water. So the moment the basket will go into the water, what will happen? Water will fill the basket, right? So water will move upward. So the moment water will move upward, what will happen? Minerals are solid particles. So mineral will get expanded to the top, right? It will move to the top. Expansion will happen. Is it fine? The moment you take out the basket from the water, water will drain out. So the moment water will drain out, it will also allow the mineral to settle down again in the basket itself. Okay? So this will happen. Huh? The first cycle is called what? Pulsation, which is the expansion of the mineral, right? And second cycle is called suction. Suction, right? Suction, or we also call compaction or whatever. Huh? So this will happen, right? At the point, if you remember, if the pores or the voids in the basket is bigger one and the mineral size which are smaller, they can also pass away, right? They can also easily pass away if they are heavy also and they are finer than the size of the voids, right? Okay, this will happen, of course. This is the situation. So my point is, in jigging, there are two different kind of jigging we can do. In one kind of jigging, you can do like what? You can do either sink and float. Sink and float, or I can say what? Sink means that is underflow and underflow and overflow. If you remember, right? Underflow means which will pass away, which will go towards the bottom. Why they are going towards the bottom? Because they have more denser now. So settling velocity is more, or terminal velocity is more. So they will settle at faster rates, right? So same thing, sink and float. Sink means they will go down. Float means they will float on the top because they are lighter, right? They are not heavier, they are lighter, right? So this is one of the things. But another concept is this one, what I told, stratification. So in the stratification, what exactly happening? The particles are not going out of the screen. They will remain on the screen at the end. But they will form different layers. But in this case, what is happening? If the particle size is smaller and heavier, they can pass through the screen and they will go to the hutch, if you remember. Just check the diagram, hutch. Right? Hutch is the bottom part of the container. Jigging machine. Right? You understand my point? Suppose this is the screen, for example. This is the screen. And this is happening, underflow and overflow. So what will happen? The particles, which is small particles, they will pass eventually. They will not stay on the screen. But the particles which are lighter, they will come out. That is called overflow, if you remember. Right? But this part is actually called stratification. So in stratification, the screen openings are not what? They are not bigger. The particle size are bigger actually. Whatever the particles, minerals are there, all are bigger than the opening size. So you do many times these things. You allow the bucket to go inside the water and come out. Go inside the water and come out. If you do many times, finally they will arrange themselves according to their density. Okay. So denser mineral will be at the bottom, then less denser, then less denser, less denser, right? You understand my point? So these are the concepts. You can see this is the starting point where all are in mixed form. Right? All are in mixed form, right? So pulsation starts. Pulsation start means you allow the water to go into this. Okay? You allow the water to go into this. So when the water will go, it will expand the minerals. All the minerals will get expanded. They are freely floated kind of thing. They all are freely floating, right, in the water. So in this condition, what will happen? This will start. Differential acceleration. Okay? How differential acceleration is happening? You are allowing the water to go from the bottom to top, and particles are getting expanded. So lot of space are available now. They can move easily. So particles which are heavy, they can overcome the flow of water. They can move down. Even if you are flowing water, they can move down also. Right? So you can see what is happening here. Just see, the denser mineral is going down. Is it? You understand my point? So that is actually differential acceleration. Differential acceleration means each particle will accelerate at a different rate. The particles which are heavy or denser, they will accelerate at faster rate. They will come down. That's why you can see shredded particles are at the bottom now. So this is called differential acceleration. Okay. So next is what? Hindered settling. If you remember, hindered settling and free settling difference.
Interaction, no interaction.
Actually, free settling means, is suppose you have a water container. Water is in still condition. Still, water is not moving at all. It is in still condition. I will allow my minerals to fall into that water. So these particles will freely fall at the bottom. So that is free settling. But condition applied. The volume fraction of solids should not be also very high. If volume fraction of solids will be very high, they will also interact with one another. No? That may be the chance. So that becomes hindered settling. But the amount of particles, if it is very less, and water is in still condition, and the minerals are moving down slowly, that is free. They are not interacting with one another, and water is in still condition. But if you allow the water to flow from the bottom to top, you are intentionally allowing the water to move. Water is also moving, and you have lot of minerals. So lot of minerals means they will interact with one another, and water is also flowing, right? So that becomes hindered settling. So same thing will happen. So you just understand up to this is static condition, same. But this is pulsation. But that means water is going, water is filling the screen. Okay. So this condition will start at what condition? Hindered settling. When water will drain out. You understand my point? Hindered settling will happen when water will drain out. Because water is draining out means water is moving downwards again. So it will also carry the particles downward. It will help the particle to settle faster. Of course, no?
Yes.
It is not a still water. Water is going up and again coming out through the screen. So that's why it is called hindered settling. Water, these particles want to settle easily, freely, but water is also going down, right? So it will become hindered settling, of course. So hindered settling will happen, and finally this condition will reach. See what is happening? You remember, if the particle is coarser and denser, that will have more terminal velocity or more settling velocity. That will settle faster, of course. You understand my point? That's why the situation is the bigger and denser particle is at the bottom on the screen, right? And these are nearly close. Why? Can you tell me why these are close? This is denser and this is bigger. But they will acquire same terminal velocity. Why? Because you remember, if you have coarser particle and finer particle, coarser particle will acquire more terminal velocity, right? But here condition is you have fine particles, but that is denser also. So that's why they become equal. You understand my point?
Yes.
Suppose I am taking two fine particles. One is denser, one is lighter. So denser particle will acquire more terminal velocity or settling velocity. But here condition is I have coarser also and denser also, but small particle. So they will acquire same terminal velocity. That's my point. But finally, what will happen? The particle which is small, not coarser, which is small, and neither denser, lighter. So it will remain on the top. So this is the situation actually. Fine. So what can be done? So you can remove this one by using a gate. You can remove these particles by using a gate. You can also remove these particles by using a gate. Different particles can be removed one by one. Right. But we are not doing that. We are going to the last stage. Here you can see the last stage is what? You can see the term consolidated trickling. But what is the meaning of trickling? Trickling means if the particle size is very small and they are denser, they will also go in through the interstitial voids of the particle and they will reach at the bottom. You understand my point? That should not happen actually. Why this is happening? Because particle size is very small and they are denser, and in the big particles there are some voids, there are some space, right? So that's why they are going down. So that's why interstitial trickling will happen at the end actually. When everything will be completed, finally they will go down and sit at the bottom. Okay, that is called interstitial trickling. You understand the point? These are the points. So when pulsation is happening, differential acceleration is happening. When hinder settling is happening, this is the situation. And when consolidated trickling is happening, you can see the fine particles are at the bottom also, with the coarse and denser particles. So this is called, this is all about your jigging process, principle of jigging, but this is called stratification. Because each layer has different density, or each layer has different size, whatever you can say. This is fine. But the difference is what in stratification, none of the particles will pass through the screen. They will stay on the screen itself. But in this case, they will pass. Okay. Okay, then tell me, this jigging process will come under which concentration process? Already we have discussed that. Gravity concentration, of course. Right? We have different concentration processes. We are discussing right now concentration. So gravity concentration means what exactly? What is the principle of gravity concentration?
Particles should be same, but they should be classified on the concentrated on the basis of their specific gravity.
Specific gravity, very good. If you remember, just before concentration, what we are doing? We are doing classification, right? And classification, before classification, what we are doing? Grinding. So grinding is done. Particles are very fine. You have to do classification. Classification means difference on the basis of sizes. Then finally you are reaching to concentration, which is the last stage. If you remember, there was a question in the mid-semester. What is the fundamental operation or what is the main objective of mineral processing? If you remember. There was a question in the mid-semester. What is the main objective of mineral processing? Many of people have written right answer and some have written very bad answer, I have seen. There are actually two main objectives of mineral processing. The first objective is what? Liberation. I told many times, liberation or release. Because when you are mining the minerals, the gangue and valuable minerals are together. All are together. We have to separate them. We have to separate. How we can separate them? By doing crushing and grinding. That is actually called liberation. We are releasing the valuable mineral out of the gangue mineral. So that is the first objective. What is called liberation or release. But once you are doing liberation, you have gangue particles and valuable minerals are together actually, right? So next step will be what? Separation. Just you need to separate them. So these are the two main objectives. Whatever we are studying about mineral processing, we have to do liberation, then we have to do separation. And separation can be done by the how? By the concentration process. Right? And liberation can be done by combination, crushing and grinding. It's a very simple question and very simple answer. Okay, anyways, so you understood my point that this okay, so gravity concentration actually depends upon what? It depends upon difference in the specific gravity of the minerals. Basically what happened? Now in the concentration process we have to separate concentrate out of tallene, if you remember. Right? Tallenes are what? What are tallenes? Unwanted minerals. Right? That means the gangue are there actually. Tallenes are nothing but your majority of gangue. Concentrate means majority of valuable minerals. Suppose iron, take example of iron ore. If you do concentration of iron ore, in the concentrate you have hematite mostly. But in the tallene part you have silica, alumina. It doesn't mean some hematite will be there. Some hematite will be there also. Some silica and alumina also will be there in the concentrate. But concentrate of iron ore means you have only mostly hematite, Fe2O3. But in the tallene part you have SiO2 and Al2. Right? Similarly, if I am talking about aluminium ore, then can you tell me what is in the concentrate of aluminium ore and what will be there in the tallene of aluminium ore? Tell me just. There is a question of what are the gangues in the aluminium ore. Right? Hematite will be there in what? Gangue, very good. Anything else? Only hematite. Silica will be there, very good. Kaolinite, yeah, okay, fine. That is silica. Quartz, that is also silica. TiO2, not titanium, TiO2, oxide. So in the aluminium ore, three gangues are there. One is the hematite, Fe2O3. That's why the ore of aluminum is reddish color. That is the reason, because hematite is there. Hematite is red color actually. So Fe2O3 will be there in the tallene, TiO2 will be there, and SiO2 will be there. That is the tallene part of the aluminum ore. But in the concentrate part you have Al2O3 mostly, or aluminum hydroxide, a bauxite, which one we are talking about, or it is gibbsite or diaspore, whatever. Gibbsite, diaspore, if you remember. Up to this it is fine, no? So finally I am concluding. So jigging process comes under gravity concentration, and in gravity concentration the principle behind the gravity concentration is what? Difference in terminal velocity or difference in settling velocity, and which will depend upon what? Which will depend upon the specific gravity of the mineral. Okay? Is it fine? Because gangs are basically what? Lighter always. Silica is actually lighter, alumina is lighter, but this hematite, these main minerals, they are always heavier actually. Okay. And if you remember, okay fine, you can write one example where this jigging process is done. Basically jigging process is done for coal, if you remember, washing of the coal. In the previous lecture we have discussed, no? Anybody remember what is the difference between the concentration of coal and concentration of mineral? What is the difference? If you are doing jigging, then what is the difference? Concentration of coal and concentration of any mineral, maybe your hematite or maybe your bauxite, whatever. I told this one. Achha, what is the main gang in the coal? Yeah, ash. But what is that? Silica. Mostly silica are the ash, always. Okay, coal contains lot of ash, that is silica, and some amount of alumina will be there, right? So if you do jigging, right? If you do jigging means concentration, right? And you want to do overflow and underflow. So underflow will be your gang actually, silica and alumina. They are heavier than coal, and overflow will be your coal particles, which you want, pure form of coal, right? But if you do mineral processing of any mineral like iron ore or bauxite, then your underflow will be what? Your valuable minerals. They are heavy, but silica and alumina, they will go as overflow. So that is the difference you have to remember, right? Coal is very light. And any difference between coal and your main minerals? Coal are actually organic materials, hydrocarbons. But the minerals which you are dealing, like iron ore, they are actually inorganic. So that's why if you remember what is the definition of mineral, even if you cannot able to write definition, some people didn't write the definition of mineral. There was a question, difference between ore and mineral. Some people didn't write it, and somebody told it is school level question. See, I have the text with me. Somebody told it is a below school level question, but you cannot able to answer it. Okay, anyways, is it fine up to this? We will move to the next topic and we close it. Okay, you can write. This jigging process is carried out for coal washing to remove the can. Second one, it is used for gold, concentration of gold also. Concentration of gold. I told one example if you remember. Some people explore in some forest where there is stream is flowing. They will take out the sand and do like this, right? Many times they will doing like this. So what will happen? The fine particles will wash away actually. With time, if you do many times, if you do also like this also many times, the fine particle will wash away. Gold particles are very heavy actually. 19 if you remember, the specific gravity is 19, they will settle. The specific gravity of silica is how much? 2.3 to 2.6 something. But gold is 19, you can see, very heavy. You can also explore. But the point is, don't go to any forest. The point is, you might be attacked by any tiger or someone. This is happening actually, really happening. Because you are cutting the forest, right? So where they will go? They will roam here and there. Many incidents happen like this. Suddenly a tiger will attack you within a fraction of a second. Anyways, so we'll move to next, that is flotation. This is also concentration. I think don't be greedy. So don't be greedy that you want to find goal and you lose your life. Anyways, so this is flotation is the next concentration process. Can anybody remember this one at least? I told you this in the earlier class. Flotation. Or technically it is also called float flotation.
We use for sulfide.
Sulfidose, very good. Float flotation is basically used for sulfidose. Why? So this is a question.
Hydrophobic, hydrophilic.
Why is basically sulfidose? That is the question. Not oxide.
Sir, sulfide is hydrophobic nature.
Sulfide or hydrophobic. Very good. You have to remember there is a concept called natural floatability and acquired floatability. Natural floatability means there are certain minerals, they are naturally floatable. They will float easily. They are sulfide ore actually. So sulfide ores are naturally floatable. You don't have to add any kind of reagent basically. But in the real situation we are adding lot of reagent to make the process more efficient. It doesn't mean we are not adding other substances or other reagents. We are adding to make the process more efficient. But basically sulfide ores are floatable, naturally floatable. Acquired floatability means what? We are adding some reagent intentionally to make some mineral floatable. For example, iron ore. Iron ore is not floatable naturally. The Fe2O3. You want to float the Fe2O3 for example. It is not naturally floatable. So intentionally we are adding a reagent so that that reagent will go and form a coating around the iron ore and it will become float. That is called acquired floatability. You understand my point? Natural and acquired floatability. So flotation simply means what? Suppose this is a container and you are feeding two minerals, this size for example, same size, it may be same size completely. So what will happen next is, and you have water for example, water plus air bubble. See, two things are there. In this container I have water and air bubbles. I am giving a simple example. You take a bucket, right? I don't know, you people have washing machine maybe in your hostel?
Yes.
So are you using, all of you are using washing machine? Anyways, fine. You take a bucket for example today and you take water and you add some washing powder into it. And you allow the water to fall very fast, at a very fast flow rate. So what will happen? It will start forming foams. Actually those foams are nothing but air bubbles actually. Right? Those foams are actually air bubbles. Air bubbles means what? Inside the bubble it is air, outside it is water. You understand my point? Inside it is actually air. So air is getting trapped in the water itself. Okay? So those are air bubbles. So that is the situation here. You can imagine. You are putting two minerals and you have air bubbles and water. Right? So what will happen? Some mineral out of these two minerals, suppose this is A and B. This is mineral A and this is mineral B. If mineral A is hydrophobic in nature, but mineral B is hydrophilic in nature, these are two different terms, hydrophobic and hydrophilic. Some people also call aerophilic. Aerophilic means they will attract towards the air or air bubbles. Or hydrophobic you can say. So this A is for example hydrophobic and B is hydrophilic. Or this is aerophilic also you can say. See what is the meaning of hydrophilic? Hydrophilic means in water loving, some people call water loving. They have love towards water. So they will try to live in the water itself. Right? On aerophilic or hydrophobic basically means they will repel away from the water. They don't want to stay in the water. They will go away from the water. Right? So if A is hydrophobic and you have bubbles, so these are suppose bubbles. I am shading it, so for any confusion I am shading this. This is bubble, air bubble. Or I am writing foam. And these are water actually. So this is your water. So finally what will happen? This A is hydrophobic, so it will attach to this. So it will attach like this. So this is A, I told already, this is A. And this B will go down and finally reach at the bottom. This is B. Fine. So this is the situation. So what will happen? You know that if air bubbles will be there in the water, they try to collapse. So how they will collapse? They will come to the top and become collapsed. They will not get collapsed inside it. They will come to the top of the bucket, for example, completely top to the atmosphere, and they will collapse. Right? So that means at the end of the day, what will happen? This will move like this and reach here. This already reached, and this will also go and reach here. So finally, you have, for example, this one, and this one. These are the A. And what can be done? You just steam it, just remove it like this. Or if in industry, what is exactly happening? Lot of bubbles are moving and carrying the mineral particles, A particles. So when it will be too much, so it will automatically flow out as an overflow, you can say, right? It will automatically flow out, and they will put a container to collect all these A. So all the A minerals can be coming out from this container. And B will be there at the bottom of the container. That is, we want to separate them, right? So already we did separation. We separate the A and B. So A is, for example, your valuable minerals, and B is your gangue here, right? So for example, chalcopyrite, if you remember, chalcopyrite is the principal mineral of which copper. Very good, copper, right? So if chalcopyrite contains like silica or some other gangues, so they will become B here, and chalcopyrite will become your A. Okay, fine. So this is all about your flotation. We'll discuss in coming lecture better, right? So I am finally saying the flotation or float flotation depends upon what? Depends upon the surface nature of the particles or of the mineral, right? Some minerals are hydrophobic, some minerals are hydrophilic.